This is quite urgent. So the behavior described is the device starts. Basically, it behaves in a loop. So the device starts and then shuts off, and then starts again, and then shuts off, and then starts again, and then shuts off. So right now, I don't see the device coming on. Let me try to switch it on. Oh, by the way, with the T2 devices, so they have this function where the lead open function, where when you lift the lead, it basically starts the machine. So, but that will be when the device is in a state to do so, which is you have a charged battery, for example, or you have a power charger connected to the device. So right now, what we see, it doesn't start. So I suppose that the battery it's down. So ordinarily, I wouldn't connect power to a machine, but given that it is stated the device power is on, so I would assume it's not liquid damage and it's safe to power to connect power to the device. So I'm just going to connect our charger to see if it does what it's described. Okay, I get a feedback on the trackpad. See, okay, so say starts, and it seemed to be stable. Okay, so I'm not sure what okay, so let's see if it's gonna go off. I think it's off now. Is it off? Okay, I think it's off. Okay, I see. The device is off. So let me see. So so usually whenever you get a device that goes off, so what I do is I try to understand from what point and what comprises what the device is doing at the point it goes off. So usually, so as you see now, what I have done now is I held down the Alt key to get my boot option. I want to see if the device shuts off from the boot option window. Now the reason why I do that is I'm trying to isolate, or I'm trying to narrow down exactly what are my possible issues. So now that now that I hold down my Alt key on my boot option, I'm just gonna wait a bit and see if it goes off from this from this section. If it doesn't go off, but only go off when the device is trying to load, that will give me a different clue. So for time reasons, what I'm gonna do is I'm just gonna go ahead and then reinstall the machine, but then I have to put the machine in DFU mode. So I need a secondary machine. So because I see now that the device, let's see, we have a drive. Let's try to click on the drive and see what happens. So would the device not doing anything but just idle within quote, we see that it doesn't shut off. But let's try to click on the drive while the machine tries to load and see what happens. So if we let's see. Okay, it's not correct. Up until this point, the device is fine, but when it starts to go into internet recovery, I suppose this is where it shuts off. Okay, and it's off again. So the first thing we're going to do is we're going to reinstall the machine and then try it again. So it's to put the machine in DFU mode, we are going to have the cable connected to the second port. Again, I mentioned if this was an M1 devices, we are going to be using the first port, but because it's Intel, we are going to use the second port. And DFU machines are machines for DFUs are from 2018 and above, which is from your A1989 or your A1990 and above devices with T2 chip. So I'm going to have my cable connected to the second port. Now, what I'm going to do is I'm now going to force the device into the DFU mode. On my secondary device, I want to make sure I have my Apple configurator too. So I have that open. Now I'm going to press. So I'll need 4 key combinations: the power button, the control button, the option button, and the right shift. Not the left shift, the right shift. So I'm going to do that, and then I'm going to count to about 10 seconds. So it's going to be 1,000, 2,000, 3,000. And that's it. So another thing is when the device is on, you can when the device itself is on, you get a quicker access to DFU compared to when the device is off, which is exactly what you guys saw. Around about 4 seconds, we're able to get the device in DFU mode. But if the device was completely dead or the device was off, you might have to count to 10 seconds in order to get the device in DFU mode. Okay, now that we are there, we know that the client has also given us a go ahead to erase. So there are 2 options that we usually would use. The first one is when you go to advanced, you go to revive. So under revive, your data is going to be saved. But when you use the option of restore, you will lose your data. But in this case, the client has given us a go ahead to erase the device. So now, if you already have the file downloaded, it's not going to re-download the file. It's just going to extract and then install. But if you don't have the file downloaded, it's going to do it as we're seeing now. Now, for time purposes, so what we are going to do, we are just going to leave it to do its thing. I'm going to grab another machine, which is a MacBook Air that needs a repair. So we will start with that one while this is doing. So while we're waiting for the download to okay, and then we have a MacBook Air here. It says got 3 different job cards here: H0 2020 and 21H3. Came in for rework at the time, and now it says it's dead, but with a different job card number, which is 3085, and it's just dead. Just as it just seems the device has been getting lots of comeback. Okay, so this is this is a MacBook Air. It's an A1466, so it's got a MagSafe 2, so which would mean that it's from 2012 and above, and it says that it's dead. So quickly, let's take the back cover out to get to understand what is going on here. And also, it seems the device, see, most of the screws are missing, so it also seems like the device it seems like the device has been in and out for repair. Okay, so because of yeah, because of that, because of the JTAG, the size of the JTAG, we can tell that this is a 2015, 2017, and we have signs of there's a flux. I'm not sure what's happened here. Okay, let's disconnect the battery. I'm not sure what has happened here. It looks like definitely there's been previous work on it. We have a missing screw here as well. So let's have a charger connected. See what we get. We don't have any charger communication. Is that it? Maybe earbud cable is not properly connected. Let's see. Do we have a Let's check to see if we have a voltage on our PPDC in. So we can check for PPDC in voltage on the DC jack connector itself. So let's see. We do have PPDC in voltage. We have PP3V42. We can check on this inductor here. We do have PP3V42. Do we have PP bus voltage? And we have PP bus voltage, and also SMC is communicating, and then we get 8.6 because we have SMC communication. Okay, so let's see, is the device partially in SO state? Yes, the device is actually in SO because we're getting 5 volt on this inductor here, and we will only do so, we'll only get 5 volts there when the device itself is partially making its way into SO state. Okay, so let's take the board out. We see that the device is making its way partially into SO state, but wait, the fan. Okay, let's see. Do we have something on the screen? Oh, nothing. Okay, so because the reason why I'm thinking maybe we have something on the screen is because I see on the fan connector, the connector clip, it's also not there. But so I'm just thinking maybe the fan is not making proper connection, and actually the board is also warm. Okay. The board is warm. So what we want to now do is, so we are going to take the board out and then see what rail is not present, which is why the device is not starting. So when you have a situation of the device partially making its way into SO state, that is less of an headache because then it's a bit easier to narrow down because you already have most of the required power rails available, which is why the device is able to make its way into SO state. So we are going to take the board out and see what rail is missing, and then once we're able to narrow that down, then we should have the device up and running. The screw here looks uh, okay. At the same time, we're keeping an eye on our 16 inches, so it's downloading the required file. Okay, so this is a 2017, not a 2015. Okay, so let's put the shell on the side. Okay, so I see the file is almost done. So okay, it's unzipping now. Let's wait for it. Let's finalize with this one and see. Yeah, it's fine, not a problem. Because we're basically on the same. Now the pop-ups that I'm getting, that is mainly because I'm using an M1 device. If I was using an Intel device as my host, I might not get the pop-ups. So that's something to also take note of. Okay, so the device is starting now. We are going to hope that that fixes the problem. If not, then we'll have to take the board out. It is standard for the device to go off. It's not a problem. So I'm looking through the MacBook Air. So I see, okay, so this is also a good sign. Whenever you get that, that's a sign that the process was successful. And a log sign, it's basically the final step. So once you get the log sign, it means that the device itself, you see, it says the state of the device is booted. So that is good. Now, so what you want to do is you want to press and hold on the power button to shut it off. To confirm it's completely off, the booted state will change. And that, you see, it's gone. So now we can power the device back on. So the log sign also means that my device is powered back on. I'm just going to give it a bit of time in order for it to start on my primary device. And then another thing is that the only reason, obviously, why we still have communication is because we still have our cable connected. So with our cable disconnected, then we will no longer be able to access the device. Okay, so the device is started. So we are now going to try it again and see if we have a different response. Okay, so let's try to put the device to recovery. So we're going to hold Command Option and R. We can as well use the Command R, but we're trying to get the latest software for it. Okay, so initially, before the restore, the device would go off while loading. So let's see if that's the case now. If it still goes off, then definitely we have a problem. Then we'll have to pause. Okay, that's different. Before now, the device will go off. We won't even get the loading bar. So the fact that we're getting that, that's beautiful. That's fine. So what you're gonna do is while it's doing its thing, we're just gonna put it on this side like this, and then we can continue with the MacBook Air. Now on the MacBook Air, let's now switch to the board view. This is an A20-00165. And we confirmed that it's a 2017 board. The board number for 2017 is the same as the 2015. So it's going to be 80-00165. Okay, so let's we confirmed that the device itself is making its way into SO state, which is good. Is this obstructing you? Okay. Okay, so I have looked around the board. What I have seen, which does not necessarily pose a problem, is the cap. This cap here is missing, and then we also have a broken component here. I'm not sure what this component is. If that is a resistor, then that's going to be something of concern. But if it's a capacitor, depending on what type of cap it is, the role of the capacitor, then we might not have to worry at the moment. So let's see, what is that? So it's this guy is present, and then that guy. Okay, yeah. So that is a capacitor, but it's a relevant capacitor. So we need to put that back. That is not as broken off of the board. That is C7311. So it's this guy here. It's this guy here. It's broken off of the board. So let's put that back first, and then. And then another thing is so when you are concerned about your capacitors, yeah, sometimes depending on the role the capacitor is playing, that will determine if you need to put it back immediately or no. So right now we see that even though this is a capacitor, but this is a capacitor that plays an important role. So we are definitely going to put it back. So it's C7311. We're going to put it back, and then right now we cannot confirm if that is the only issue that we have on the board. But then first we need to put it back and then continue from there. And then also the beauty part of it is, like we said, the fact that the device is partially making its way into SO state would mean that this might not be such a difficult issue. So I'm just gonna again connect our charger to it just to confirm what we have on the board. Charger is connected. Okay, so on the other side of the board, this guy here, L7520, you see we're getting 5 volt on L7520, and that is because the device is in SO state, so 5 volt. If we were not in SO state, because PP5V underscore S4 out S3, and we're getting 5 volt here because we are in SO state. If we were not in SO state, we will not get 5 volts there. So let's just confirm that that is still the case. That inductor that I'm pointing to is this guy here. If we check on the side, you see that we are getting a 5 volt, but then our fan is not spinning. So what we want to do now is we want to put back that cap that is missing and then see what happens. Let me grab another board. Okay, that's in place. Let's see that guy. Okay, so this cap here, the one that is missing on the backlight region, which is this guy here, we do not need that capacitor in order for the device to work. So with or without the cap, the device is still going to work. Although we are going to put it back, but for the current issue, we don't need the device. We don't need the cap to be on the board. So let's see with the cap back. Let's see what we get now. Okay, so it doesn't seem to start, but let's just confirm that we still have the device making its way into SO state. Okay, the device is still making its way into SO state. Okay, now, so what we want to do now is we want to go to our schematic to identify what is present and what is not present. So let's go to 80.00165. Let's see. Okay, here we go. We are now going to go to, let's go to page one. Let's go to page one. From there, we can now go to the power aliases, which will list the list of the required power rails that we need on for the machine to function. So we are going to go to, we see where it says power aliases, which is page 62. We are going to now go to page, so it's going to be page 62 and 63. So let's start from page 62. So we are going to say go to page 62. Now on page 62, this is giving us all of the rails, the required rails. Okay. Now this page, this is a page that gives us a list of the parameters that we are expecting to get on the machine in order for the machine to function, depending on what state the device is in. So we are going to start from the top, even though they are not arranged according to how they are not arranged according to how the device the rails themselves are present. So PP bus will be the primary voltage rail if you have battery only connected. But if you don't have battery only connected, the first rail that will be present will be your PPDC in, because PPDC in. So I'm just gonna go. Let me just come here. So let's go back to this guy here. Now PPDC, so PPDC in will come from here, which is your DC jack, correct? It's going to come from J7000. Now PPDC in will only be present if you have a charger connected. But if you don't have charger connected, if you have your battery connected, then you by your J6950, that will be where your PP bus will be present, which is going to come from your battery. So now, like we are saying that the what we have here, it's not in order directly how as it is now. We are using charger for our troubleshooting, so we are going to skip PP bus. And then the reason why we're actually skipping PP bus is because we confirmed that PP bus is present. Now I'm just going to show you guys that PP bus is indeed present. So this here on our fuse here, we can get our PP bus voltage. You see where it says PP bus underscore G3H. That is on the fuse. So PP bus, let's just confirm that fuse there is this guy here, this one here. So we confirmed before that it is present, but we are still going to confirm again. So, and it's 8.6 on one side, and the other side is also 8.6. So PP bus is present. Let's move on. Now so we confirm. So here it says PP bus, and that will comprises of, which is going to be equal to PP bus, and then it gives us the voltage, which is 8.6. Now all of this here, it's PP bus. So we've confirmed that we are PP bus. We are going to move over. So this is done. We're now moving to the next one. So this is now all of this now we confirm is done. We're now going to move to the next one. Now the next one also starts with PP bus underscore S5 underscore HS HS underscore computing underscore ISNS. Because we have PP bus and the start of this rel is also PP bus, 9 out of 10 this is going to be present. But for the purpose of troubleshooting, let us still confirm that that is present. So what we are going to do is we're just going to copy that. We are going to copy that line and paste it on our board view. Paste it on our board view. That will show us the location where that rail is present on the board, and then we confirm if it is present. Let's see. I think I copied the wrong line. No, so, okay, we can just reduce it to this. Let's see, from here. Or, okay, we can just do this from HS. Yeah, it's easily copy that. Okay, yeah, that's it. Let's see. So now it shows us where that rail is present on the board. So we can measure using any of these caps on the edge of the board on this side here. So those caps there, one of these guys, we can use any of them. So let's see. 9 out of 10, that is present. And then as you can see, we have 8.6 because that is an extract from your PP bus. So let's go back. So now we've measured that is present. So we are not gonna now this also this page, these numbers that you see here, that is where you will find PP bus. This PP bus will be present in 4150. All that's where you find it. Now, having confirmed that we have it, we are just going to move on. We're just going to just move on. So this is done. That is done. We're now going to move on to the next one. The next one also, we're not going to worry about it because it's virtually the same thing. Now, PPDC in, we are not going to worry about PPDC in because we are using a charger. and we have PP bus underscore G3 hot. If we did not have PPDC in, we will not have PP bus, correct? So PPDC in, we are going to skip PPDC in, and then PPDC in underscore J3H, we're also going to skip that. Now PP3B42, we did confirm before that it is present, but I'm just going to copy it again, and then just to show that indeed PP3B42 is present. So I'm just doing the same thing. I copy and then I paste, and then I can we get all of where the PP3B42 it's present. So we did use this inductor before to check. This inductor here, L7095, is this guy here. So we are going to check using that, and we can see that it is present. Okay, so moving on. So that is present. Now the same thing we are going to do. We are not going to worry. Because we've confirmed that people is present, all of what is equal to, we are going to skip that and move to this. So we are going to skip all of that and move to this. Sometimes you may have to go back to a rail that you have skipped. That will be in cases where you have issues with a broken line. So you have, say for example, you have a voltage that's supposed to start from point A and makes its way to point B. Now at point A, we confirm that the voltage itself is present, but now the point B where that voltage is required to power a rail is not present there. So there might be a breaking line. In this form of troubleshooting, if you find out that the rail is present, the voltage is present at point A, you assume that it should also be present at point B. Now, you may down the line find out that that rail is not, that voltage is not present where it's supposed to be. That will now have to take you back to what you've already passed to be said to be good. Because right now we just assume that PP3B42_G3H is present because we can see that it's present on the board, and more so because of the fact that the device itself is making its way into SO state. So we are going to skip all of that and then move down to PPVRTC, which is the clock circuitry. So we are going to do the same thing. We will copy that and then paste it on our board view. So you copy and you paste, and that will give us where the rail, it's where the voltage is present on the board, and we can confirm that we have it present in any of these three capacitors here, and on the board that will be, it's our guy, that will be, let's say, okay, that will be these three guys here. So 1, 2, 3. So let's see, we're supposed to get 3 point something volt, and yes, we are getting 3 point something volt. We can also measure it here in this cap by the chip itself. That is the RTC regulator IC. And yes, we have it, and it's stable. Okay, so that is present. The next, so we are going to move on. Now let's check for our 5 volt line, 5 volt in S5. Let's see if that is present. Five volt. We can check for that here, and it is present and stable. So you also want to make sure that it's present. So because the same thing, we're just going to assume it's present in all of where it's supposed to be and move on to the next one. Now we have already confirmed that this is present because this is what we measured on the inductor. I'm just going to again show you guys. We did confirm that that is present because that's something that we had already measured by the inductor. If we go to the other side, this is the inductor here. This guy, remember we had already measured 5 volt there. I'm just going to confirm again. On the other side of the board, black probe on ground, and then a red probe, we use this inductor that is 5 volt, and then on the other side, because it's an inductor, definitely it's also going to be 5 volt. Okay, so that is present, and again we are going to leave all of that and then move on to the next one now, which is a 5 volt underscore SO. And then you also see that the state are going to be different. Yeah, so here is S4 and then here is SO. So let's copy that and then see if that is present. We're also supposed to get 5 volt. We copy and we paste, same thing. Let's see, where are we supposed to get 5 volt? Okay, so on the edge of the board, on the other side of the board, we're supposed to get 5 volt here. So black probe here, and then red probe, 5 volt, it's present. Okay, that's good. Let's move on. Same thing, we are going to skip the subs. If we have it there, we are going to skip the subs. Then let's move on to the next one, which is pp3v3 underscore s5. Same thing, we copy, we go to our board view, and then we paste. Okay, on the other side of the board, we can get a three. Okay, we can get it, but on this side of the clock chip here. Let's see, do we have it? Yes, we let's just confirm that. Yes, we have it and it's stable. Another thing, again, you want to make sure that the voltage is not only present but also stable. Okay, so we are going to skip all of that and then move down to pp3v3 underscore s4. We copy and we paste. So what we are looking for is we're looking for what is not present. That's going to be our destination. So let's see, we can measure that by C3286, and that is going to be C3286 is going to be this guy here. So it's going to be this guy. So on that side, what do we have? We have 3.3 and it's stable. That's fine. Now moving on. So we are going to skip all of that and move on to source. Source is 100% present. I mean, if we didn't have source, we would not even be able to make our way partially into SO state. But nonetheless, for the sake of troubleshooting, we are going to confirm that our source is present. So we copy that, we paste as usual, and we can get a source here. Yeah, we can get it here. And as you can see, our source is present. Okay, so let's move on. We're also going to skip all of that and move down to pp3v3 underscore s3. We copy and then we paste. We can use this pad here by the clock chip, which is this guy here, and it's present and stable. Okay. Okay, so same thing, we are going to skip all of that and move down to pp3v3 underscore so. Copy that. Same thing, we'll paste. That shows us where we can find pp3v3 underscore so. Okay, we can use U5540, which is going to be this guy here. So black probe on ground and red probe. Let's see, do we have so? Yes, we have pp3v3 underscore so, present and stable. Okay, so same thing, we are going to move past all of those. So moving past all of it, and then go down to, so let's not worry about pp3v3 underscore s4 switch for now. We're not going to worry about that for now. Let's move down to pp3v3 underscore so switch ssd. Now we're not going to worry, that is an xx, that is going to be from our so, so we're not going to worry about that for now. pp3v3 underscore s4 tbt thunderbolt power, we're not going to worry about that for now. Let's now move down to the 1.8 volt s3. 1.8. Wait, looks like our machine is on. Okay. Yeah, this is annoying because we need to find out exactly why It's because this is going to be like a random performance. Uh, and we cannot really work with that. We need something stable. Okay, so let's disconnect and connect again. I don't want it to work because that will not be a solution. Okay, yeah, that's fine. So, yeah. So I really don't want it to work because that's not going to be a solution. We need to find out why the device itself would not start most of the time. So as you can see right now, the device again is in SO state, and yeah, and the fan is not. And this has nothing to do with the fan. It's not about the fan connection. No, this has nothing to do with the fan. So yes, the device is in SO state, but device is not fully functional. So another thing I'm gonna do is I'm actually gonna just show you guys that the device itself is not. So this is not a case of fan issue. It's a case of device not actually starting. So as you know, even if the fan is disconnected with your screen connected, the device should it should get reaction on the screen. So let's see that. Let's just again confirm that we are in SO state. Okay, you see we are in SO state, and on our fan is not spinning, obviously, and we don't have anything on the screen. And let's again confirm that we are still in SO state. So this is not a case of fan misbehaving, it's a case of the device itself not functioning the way it should. Okay, so what I'm interested in is I don't want the device to I don't want to I don't want the device to work because that's not going to be a fix. We need to find out what is partially present or what is not present, and then and why the device it's behaving the way it's behaving. So we see the device is not on, but down the line the device goes on. So 1620, I see. Yeah, is it still in SS state? Yeah. So let's continue where we left off. We wanted to check 1.8 volt in S3. Let's see if that is present and stable. By the way, we are still our 16 inches is still on, still loading. Our network is not that strong, so still loading. But it's the fact that it's not going off actually suggests that the fix was to reinstall using DFU. Okay, so let's see. Do we have? Let's check 1.8 volt. Is it present? Yeah, 1.79. That's fine. It's present and stable. Let's move on. 1.2. 1.2. It's the power rail for the RAM. Let's see. 1 point. Yeah, that's fine. Okay, let's move on. 1.1.05. Let's see that. Okay, 1.05. We can check here. Yeah, that's fine. It says 1.6. That's okay. And then 0.6. 0.6. Let's see if that is present. We can measure that using C7462. So 67462, this guy here is 0.6. Let's see, is that present? Okay, so yeah, that's our problem. 0.6 is not present. Let's just confirm again that we have, yeah, so now that is our problem. So 0.6 is not present. So yeah, that's now where we're going to start our work from. So we're supposed to get 0.6 here, this, which is going to be from U7400, but we don't have it. Let's just confirm again that we don't have it. Yes, we don't have it. So what we want to do is we now want to go to the working condition of U7400, and then yeah, so that is where we want to focus our attention on U7400. This is the guy. So we are supposed to get 1.2. So it has let's see, not really. U7400 regulates 1.2 volt, 1.2 volt, and that is present because we did confirm. So L7430, let's just confirm again. So L7430 is that, yeah, we confirmed that 1.2 is present. So on the other side of the board, it's going to be L7430, this guy here, and yeah, it is present. So the voltage that we're talking about, this guy. So first of all, let's go to C7462. So C7462, so C7462, and then we can copy the rail from there. So this is the guy that's missing. Let's copy that and paste and see where that it's being generated from or created from. So let's paste that on our schematic. So one thing with with searching for origin of a particular line, when you copy and paste on your board view, it will show you where that rail is supposed to be present on the board. However, it will not show you where it's being generated from directly. But when you paste that on your schematic, the schematic will show you where it's being generated from. So that's the difference now. So we'll paste to see where it's been generated from. We'll paste it here. So here we see that this is it going into something, correct? It's not, we don't see a sign of it going out. This is also going into something. So let's move to the next. Okay, this is not it. Let's see. Let's just confirm if this is VTT. Okay, I'm just going to check again to see if that's all. Okay, so yeah, I think we have to go back to blame U7400. Yeah. Okay, so let's check. Let's see. Let's check around U7400. So let's go back to it and then click on it and then walk around the chip. So the first one, it's okay, we're not going to worry about that. Pin 2, we confirm that that is present. 1.2 volt, we did confirm that that is present. Is that 1 point? Supposed to be 1.2? Supposed to be 1.2. Why are we getting 1.78? It's supposed to be 1.2. Wait, we just get something. So that's supposed to be 1.2, not 1.8. We're getting 1.8. 1.8. Okay, let me get another board just to be sure that wait. Is it heating up? Maybe. Okay, let me get another board. Okay, so it just needs to confirm. Let's see what we're supposed to get here. Is it 1.2 or 1.5? 1.2, 1.8. This is a non-working board. You set up on my here. Correct. Okay, so on another board, I'm just gonna see what do we have. 1.2, and here it's, oh yeah, okay. I think I was measuring on a different line. So the line that I was measuring on was definitely the line of 1.8. Um, so I was just gonna check that. So this line here, it's a 1.8 line, yeah, and then this is the 1.2 line, and yeah, 1.1, yeah, that's about fine. Okay, so but this is not present. Okay, so now we know that's not present. That's fine. So 1.2 we confirm. Let's see. Oh yeah, so I was using the L7820 instead of the capacitor. Okay, yeah, that's fine. Let's move down. We confirm that pin 3 that is not present. Okay, and then the next one it's pin 5. Let's see. We skip 4. Let's see what do we have on 5. Pin 5 is this guy here. What do we have? 0.6. And then here, 0 still. Okay. Okay, 0.6. And then pin 6, that should be present. 1.8. I think that's going to be present. Let's see. Yeah, that is present. We'll move. Don't worry about pin 7, pin 8, feedback. Let's not worry about that for now. Let's not worry about for now. This guy here. Let's not worry about that for now. Pin 5 is definitely present. That not for now, not now, not now. Let's see, what do we have on our EN enable signal? That should be present, but let's just confirm. Okay, can measure that here. Yeah, that's present. Okay, that is present. And then MVTT power EN, is that present? We can confirm that by this R1970. R1970 is gonna be, yeah, this guy here. That's present, and then that's wait, and then wait, is that supposed to be 0? Let's check it on the working board. I'm not sure if that's supposed to be 0. It's not supposed to be 0. So we have it in and we have it out. But here we have it in, but we don't have it out. So let's again confirm that. So this is we're supposed to have it in here and then out on the other side. So but what we are getting is we have it in. Let's just confirm. Say it's in and out. Do we have it? No, we don't. Okay, so first let's replace that guy. Let's quickly replace it first. And, see if that at least we're getting somewhere. Okay, so that's replaced. So right now, what I'm going to do is I'm going to have the fan completely disconnected because I don't want the fan spinning to throw me off, because I know that the machine works sometimes and other times it would not work. So I want to have the fan disconnected, and I want to see if now, I mean, I know before replacing the resistor, we had input, we had the voltage, we had SO, but we didn't have the MVTT power EN. So now that it's been replaced, let's see if we have it present. If we don't, we might have to look into U1970. Yeah, we might have to look into U1970. Okay, let's check it. Let's see now if we have it present. So black probe on ground, and then our red probe. Let's just confirm we have 5 volts. Charger is properly connected. Okay, so we know we had it in SO. That's going to be SO. And then here, what do we have? 0 volt. Okay, so we still have 0 volt. So our problem was not R1970. Now let's replace U1970. Okay, so that is now. So after replacing U1970, if it still doesn't work, then we'll have to replace U7400. Okay, let's just confirm that we have charger properly connected. I just connected. 1.8 present. SO present, and then out. Okay, we still don't have it present, so we are now going to replace. Let's just confirm that the device itself is still in SO state. Yeah, device is still in SO state. Okay, let's replace U7400. Yeah, so let's replace U7400, and then if it still doesn't work, we again want to look around to see what's happening around U7400. Okay, that's replaced. So because we're yet to confirm that E7400 is actually faulty, I'm just going to put it back here. And also U1970, we also need to put that back. Not put it back, like put it where we took the other one from. Because I mean, indeed, it's we confirmed that it's not faulty. So Okay, so E7400 is it's put back. So let's see what happens. Oh, by the way, with the 16 inches, so I see. So this is a network issue. So we are going to use a wired network. But other than that, the device itself is working. Unlike before that the device. So unlike the behavior we had before, now the device is it's fine. The issue with it was we needed to reinstall it using Apple Configurator 2. That is done, and this is ready. So we're just gonna use a different network to install it, and that's about it on this one. So let's quickly finish with the MacBook Air because time is also running out. Let's see, do we have the device in SL state? First of all, PP bus. That's fine. SL. Okay, device is still in SL. That's fine. What do we have? 1.2 present, and okay, so that is still not present. Okay, so the next thing we want to do now is we want to see if we have a short on that line. We're going to use a diode mode. Let's see if we have a short on that line. 1.26 on a working board. What do we have? 0.97. Let's check that again. 1.2. Also, because the board is hot, that might also give us a different result. 0.99. Okay, let's try again. 1 point. Okay, yeah, that's not a point of actual concern. Okay, now what we want to do is let's go to U7400 page again. U7400 page, we know that let's see, this is present. We confirm this. Let's see, where does this come from? Let's just confirm where that well comes from. That signal comes from the CPU. Ah, okay. Ah, comes from the CPU. See where it says out? And that's U0500. That's the CPU. Okay. Let's see what's happened. Okay, let's see. Let's see what we get here. Don't tell me. Okay. But wait, before we worry, let's see. It's all bi-directional. Okay, let's see. It's not so good. But yeah, it's where is that? Do we even get okay on the other side of the board? 0 point, oh no, voltage mode, 0 volt, completely zero. Is it still in SS state? Yeah, let's check again. 0 volt. Okay, but um, let's put that back. Okay, let's see the. We know that's not present, but this guy. Okay, CPU. Okay, let's check. Let's see what we have on the P. Good CPU power, good signal. Let's see. Do we have that present? We can measure that on R0620. Okay, here. Let's see if that is present. Interesting. That signal is not present as well, which is CPU power good signal is not present. I'm just going to confirm that again. I'm supposed to this part here. Can use that. Okay, that is also not present. Okay, CPU power good signal is not present. Let's just confirm. Yeah, that's not present. Uh, okay, okay. Let's see. And here, let's CPU power. Let's see what is it that. Let's see what's happening here. This guy here. Let's check this rail. Let's check this line here. Let's see what's happening there. Yeah, it's almost time for prayers. Uh, let's see. Is that present? Let's confirm that. It's also not present. It's supposed to be. Okay. Let's see. Where does that come from? 5 pages comes from. Wait, it does that come from? And that is PCH J180. What is that? So we're supposed to get from let's see, J180, J180, J180. J180, it's this guy here. Yeah, it's nothing there. Okay, we have a resistor there that seemed to be broken off. This guy, but is that a resistor? No, it's a cap actually, not a resistor. Uh, yeah, we have a cap that is broken off there, and I don't suppose that will prevent. No, that cap is not gonna prevent the device from working. Let's see, what is this? CPU configuration. Debug. 6 power. Okay. Here. Wait. That is also not present. No, that should be present. Let's check that. The other side of the board. Let's just confirm. Is the device still in SS state? Yes. And here. Aha, we also have this guy there missing. What is that? Yeah. Yeah, so we have this guy here missing. This resistor there, it's missing. So that's one of the problem when you're working on a board that has been worked on. You see that guy? You see that is missing and it's missing there. So let's quickly put that back. And that's miss the one the resistor that is missing is supposed to be this guy here. That's PM sleep underscore also is power good. That resistor is missing. And sure, that throws us off completely. Uh, so that's one of the problem you run into when you working on a board that has previously been worked on. Okay, let's get that. Hopefully that should mark the end of the repair. Okay, so that's there. We just hope that's the only component that is missing on this board because it's time for prayers and so we have to so much today. Okay, so back probe on ground, red probe is to confirm. Okay, let's see. Yes, we have that. BB bus present. SO state. No longer. Now we get. Oh yeah, we're supposed to get 5 volt. Yes, 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 yes. Okay, my head is yeah. We're supposed to get 5 volt. That's fine. Let's see what we had 0 here. Let's see what do we have now. We still have 0 there. That's not good. 1.2. Okay, and then this. Okay, okay. Yeah, we're fine now. Remember we had 0 there as well, so that's fine. And the enable signal that we're missing here is now present. Okay, yeah. So we now have a working machine. So the one our problem was R81 8167, which was missing on the board, and that was really yeah that threw us off completely. So not sure why that was taken off the board, or maybe it broke off. I don't think it was it wasn't taken off on purpose, it was broken off. So it's quickly so we should have a working device now. And we shouldn't have a device that works on and off, so we should have fully functional device now. Fan is spinning as expected. Is it posting? It starts to post. Okay, it started to post. Yeah, and then should get something on the screen soon. The screen is actually yeah, so we should get something on the screen too. Either question mark folder or yeah, that's it. So thank you guys. The two things that we had here, first of all, was a MacBook Air that would randomly start and other times would not. It just the fan would do its thing, and the other was the 16 inches that would go off immediately it starts loading. So we for that one we had to reinstall it using Apple Configurator 2, and this one we had, and the MacBook Air we had a missing A1466, and we didn't put back together. As you guys can see, we have a working device. Thank you guys. I will see you guys in the next one.